He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
Super scientist Nanogirl is on a mission to show everyone the wonders of science. She's joined by her trusty sidekick, the constantly learning artificial intelligence repository. We call her Claire. Let's cross now to Nanogirl's secret lab.
Oh, that's so annoying. Oh, so frustrating.
By the noise that you're making, Nanogirl, my calculations tell me that all is not well.
Oh, there's something wrong with the freezer, Claire. All the ice has melted and there's a massive puddle all over the floor.
You know the freezer is not plugged in, right?
Oh yeah. I forgot to plug it back in when I was using that point to charge up the hoverboard.
No!
Oh, so annoying. Right, I'll plug it back in. That'll start freezing the water again. Now to clean up all this melted ice off the floor.
And while you're doing that, Nanogirl, let me bring up a question from Ashton in Christchurch about melted ice.
Hi, I'm Ashton. I'm 10 years old and I go to Casebrook Intermediate school. And my question is, what happens if Antarctica melts?
Do you know someone who can help answer that, Nanogirl?
I totally do. And I think the answer might be a little bit more complicated than just plugging the freezer back in.
Because the Earth doesn't have a plug.
It does not, but the jet vault does. Right, I'll see you later. I'm off on an adventure. All right, I've got to find my way to Casebrook Intermediate School. They wrote to say that they have a really cool playground that all of the kids designed. So I've got to look for a cool playground. Cool. Oh, it must be that one. All right, coming in for a crash landing. Oh, hey, that was a better landing than usual. What a cool playground. This must be the right place. Let me see if I can find somebody to help me.
Hi, Nanogirl.
Oh, hi, kids. Where am I?
Casebrook Intermediate.
Yes, GPS worked. Okay. I'm looking for Ashton. Is Ashton around here?
I'm Ashton.
Hi, Ashton. You had a question for the Nanogirl team?
Yes, I did. What happens if Antarctica melts?
Oh, that is a great question. How many of you have heard of Antarctica before?
Me!
So what do you know about Antarctica?
That it's made out of ice and snow and...
Penguins live on it. It has melting ice caps.
It's less than 50 degrees Celsius.
Is that warm or cold?
very, very cold.
Very, very cold. Okay, so Ashton, I really like your question, but I'm a nanotechnologist, so I don't know the answer, but I know an expert who might. Who wants to go on an adventure with me?
Yeah!
Right, we're going to have to fly there, though. Are you all right to squeeze into the jet vault?
Yes, baby.
It's going to be a bit squashy, but let's see if we can all squeeze in. Come with me. All right, squeeze really tight. Seatbelts on. Get ready, hold on tight. We're going to go really fast.
Are we going to Antarctica?
Are we going to Antarctica? That sounds great. No, we're actually not, because it's really far away and I still have to get you back to school today. So what we're going to do is go to the International Antarctic Centre, which actually, if you look out of your window all the way down there, can you see that dome? That tiny dome? We're going to go there. Look, I only know how to crash land this thing, so hold on.
Wait, what?
Everybody okay?
Yeah, we're all right.
Okay, let's go find Gary. Oh, I see Gary over there. Hey, Gary.
Hey, Nanogirl, I see the parking hasn't improved.
Oh, yeah, I'm still trying to work out how to park the jet vault. Anyway, I have some great kids here, and one of them has a question for you. Ashton, what's your question?
What happens if Antarctica melts?
Wow, that's a really important question. First of all, do you know why Antarctica's so cold to begin with?
No. No.
Well, you know where Antarctica is, right?
Yeah. Yes.
Right on the bottom of the planet. And you know that that's the furthest point on the planet from the sun, so the angle of the sun is really low in the sky. And that means we don't get that much heat from the sun in Antarctica. And in the winter, we don't see any sun, because it goes dark for 6 months.
Is there any way we can sort of experience what that might be like?
Well, you know, inside the Antarctic attraction, we can find a storm room and see what those cold Antarctic temperatures are really like.
Who wants to go in the storm room?
Me!
All right, let's go get some gear on.
Anyway, my love, put those on. Now the white line goes to the front, you see it when you open it up. Don't put them on your head because you look quite ridiculous.
Put them on your head.
Oh no, people do.
All right, well, we're going to go into the Antarctic room, and it looks very cold, so everybody put their jackets on. Ooh. All right, time to go in. Ooh.
It's cold.
So how are you feeling?
Cold.
Freezing. So, Gary, how cold is this room?
This room is actually not that cold right now. It's only about -8.
So is this what it would be like to be on Antarctica?
No. In the dead of winter and most of the time at the South Pole, it's more like -50 or -60, so it's really cold. You know what? It's not just cold. At those sorts of temperatures, it's also very, very dry. Why does that not make sense?
Because like the Sahara Desert is sandy, so people think it's dry and hot, and yeah.
So does that mean that Antarctica's a desert?
It does. The world's driest desert.
Because when you're imagining a desert, what do you imagine?
Sand, hot sun, cactus.
Yeah, and Antarctica's got all this ice on it, right?
Yeah.
But it's ice. It's not water. And it never rains in Antarctica. It's too cold for rain. It always snows.
I feel like there's a blizzard coming on in here.
Getting windy.
There's a storm coming! Don't blow away! Is everybody warm enough? Yeah! Okay, so it's -8 degrees Celsius in here, but you can see the wind chill with that blizzard took it down to -16. Did it feel much colder in the wind?
Yes.
And so, Gary, is that what it would be like in Antarctica? The wind makes it colder?
Pretty much. The real thing we worry about when we work in Antarctica is the wind. It's easier to keep warm when there's no wind, but when there's wind, it makes it really hard.
On average, how long could a person last in Antarctica?
If you're out in a storm like that, you couldn't last very long at all. I mean, you'd start to get frostbite on your fingers and any exposed skin probably within about 10 minutes. So, yeah, that would be okay. You could survive frostbite. But when it got worse and you started to get hypothermia after about 20 minutes or maybe half an hour, no longer probably, then that would be hard to recover from.
Then how come you're a scientist in Antarctica?
In Antarctica, some of us work in bases and in buildings, but a lot of us work outside and camp. I camp all the time, and we just dress up properly like this, with coats on, with gloves on, with hats on, with face masks on, with woolly socks on, and about probably 5 or 6 layers of clothes to keep us warm.
How long does a storm usually go for?
Sometimes in Antarctica the storms can go for weeks, so 2 or 3 weeks the wind can blow for.
Does the snow keep the animals warm or cold?
The snow actually does keep the animals warm. When there's a blizzard, the dogs, the huskies, when they used to have huskies in Antarctica, they would burrow into the snow, and all the air around within the snow particles is like a blanket keeping them warm. So and penguins actually do the same when they're around the snow. They let the snow accumulate on their feathers and use it as a blanket layer to keep warm.
How come the ice is melting?
That's a very good question. One of the ways that the ice melts is it doesn't really melt. But what we say is it loses mass. What happens is the ice is coming out of the bottom of glaciers and melting into the ocean faster than the snow is falling on the top of the Antarctic ice sheet. And so the actual volume of ice is reducing. So even though we use the word melting, it's not actually melting because we've warmed it up a whole lot. It's just that we've changed the dynamics of the ice flow slightly by increasing the temperature.
How come Antarctica's melting?
Well, on the planet, there's a layer of insulation called our atmosphere. But inside the atmosphere are lots of heat-trapping gases. They're starting to warm the atmosphere up. And they're also warming up the ocean. So as you warm Antarctica and as you warm the ocean, that's how you start to melt the ice.
Then what can we do to stop Antarctica melting?
One of the simplest things we can do is think about those heat-trapping gases in the atmosphere and where they come from. And they're all carbon-based, so it's all to do with carbon. So every time we use a car, every time we eat food that comes a long way with transport, every time we burn oil or something for heat energy, that all makes carbon dioxide. And that's one of the heat-trapping gases. So if we stop doing some of that or reduce doing some of that, that would be a good start.
I don't know about you guys, but I am freezing. Let's go find somewhere warmer to keep talking to Gary. Follow me. Oh, that's way warmer. Your ears are all pink. Why do you think your ears are pink?
Cause it was cold.
It was cold, so why do you think your ears go pink now?
Cause I'm pretty sure cause blood rushes to your ears to make it warmer.
Very good, because the warm blood from your middle that's nice and warm is now rushing to warm up your ears, which are on the outside. So we've got pink ears, I've got pink hands, but we're slowly warming up. And Gary, so Ashton's question was all about what happens when the ice melts. And so, Gary, you have a bag of ice here. What are you going to do with this ice?
You can hold on to it.
How does it feel?
Cold.
But what's happening to it in your hands?
It's melting.
And what do you get?
Water.
Yeah,
Where
so
do
what
what
happens when Antarctica melts?
Water.
You get water. And where does it go?
Into the ocean.
Yes. Is that a problem?
Yes.
Why?
Because of flooding.
Yes.
Sea rise.
Sea rise, that's right. Do you know how much ice there is in Antarctica? Someone take a guess, go on.
1 million?
1 million what? Tons? That's nowhere near.
Isn't it like 7% of the water in the world?
Well, it's 90% of the world's fresh water, but actually if you want it in tons, it's about 26 quadrillion tons.
I don't know, how many zeros is that? How many zeros is a quadrillion?
That's 1,000 million.
Wow.
Wow, that's a lot.
If you melted all of that and put it back into the ocean, the sea surface would raise by about 50 metres. So that would probably get you about halfway up the Sky Tower in Auckland.
Doesn't that mean that islands like Hawaii and Papua New Guinea and all that stuff will sink and some of the land will go?
Well, it does mean that some of the coastal areas will go underwater, but many of those islands, Hawaii, that you mentioned, Hawaii, Papua New Guinea, they all are quite mountainous. The problem is some of the atolls in the Pacific, some of the low-lying sandy islands, because they won't be able to keep pace with the sea rise. And that's why we're already talking about it on the radio. They're losing access to fresh water because the salt water's inundating all the land because of the sea rise, even at very small. So at the moment, the sea level's only rising by just a few millimetres a year. But as the melt picks up, that'll pick up faster. We know actually in the past, it's melted at a rate of 4 centimetres of rise per year.
That doesn't sound like very much. Is that a lot there?
Well, so here's the problem. It's not just the fact that the sea level is rising, but when you put more heat energy into the ocean, which you do by adding more water into it as well, and you bring it up a bit on the land, actually what happens is the storms get bigger. And the amount of water that gets pushed up onto the land in a storm is much, much more. So it's not just that you get a little rise in sea level, it's that these big storms start to pound and inundate the coastline, so they go underwater anyway.
So what you're saying is if Antarctica melts, places are going to start flooding?
That's exactly right.
How much of the Earth would be affected if the sea levels rise so high?
Oh, I think actually if you lifted sea level around the planet by a metre, that's everywhere, all the oceans, there's about 100 million people live within a metre of sea level. So that's an awful lot of people.
How long will it take until Antarctica will melt away?
That's a really good question, and we don't know the answer, and that's part of the challenge of why we're struggling to deal with it. And so we have to do a lot more study to work out exactly how it is that we're warming it up and it's starting to melt. We know it's losing mass. We can actually measure that from satellites. From Nanogirl's spacecraft, if you take some laser altimeters and measure the surface of the ice year after year, you can see that it's losing mass, and we do that.
Cool. What you're saying is I need lasers on the jet
You do
farm.
need lasers.
Awesome.
So is that what you do in Antarctica? You measure the melt?
Kind of, yes. I'm an Antarctic scientist, but actually I'm a paleoclimatologist, which means I study past climate. So patterns of weather in the past. And the reason I do that is because, we're predicting that the Earth's we're working towards 2 degrees warmer, right? The whole planet. And I can go back in Earth history and find a time when the Earth was 2 degrees warmer. And then we can see what the ice sheet did. That's what I do as a paleoclimatologist. I measure the melt, but I don't measure the current melt so much. I measure actually how far did things go last time we warmed it up.
Does that mean you have a time machine?
I do. But it's not like a spaceship. It's a drill rig. And what we do is drill down into the layers of the ocean, layer by layer by layer, and go back in time that way.
So, Ashton, do you feel like your question was answered?
Yeah, thanks, Gary.
You're welcome.
Well, thank you so much, but I'm going to have to get all of these guys back to school. So, time to get back into the jet vault. Day, Claire. We got caught in a snow blizzard and we learnt all about Antarctica.
I had an amazing day too, monitoring the temperature of the refreezing freezer.
We have very different ideas of fun, Claire. After spending the morning at the Antarctic Centre, I'm ready to go ice fishing. Hey, let's open up the secret lab. Now, most people think that ice freezes at 0 degrees Celsius, but we can actually change that using the power of salt. So for this experiment, which is called fishing for ice, you're going to need a piece of string, an ice cube, and some salt. So we're going to take an ice cube and put it onto a plate. Next, you're going to take a piece of string, maybe about 10 centimetres worth, and you're going to place it on top of the ice cube for 10 seconds. Now, after that, you're going to try and lift up the piece of string and see if the ice cube has stuck to it. Let's have a look. Nothing happened. I just have a piece of string. Now you're going to do the same experiment again, but on top of the string, you're going to sprinkle some salt. Now let that sit for a couple of seconds, and what's going to happen is the salt is going to lower the freezing point of the ice is going to melt and then refreeze over the string. Now when you lift it up, you should see that actually the piece of string is in the middle of the ice cube, and now you have lifted up a whole piece of ice using just the power of lowering the freezing point of ice. We call this experiment fishing for ice because it looks like you've caught some ice on the plate. It's very easy to do. And if you've ever seen in cold countries that people put salt onto the roads in the winter, it's for the same reason. It's to reduce the freezing point of the ice so that you don't slip when you're in your car.
Uploaded. To have your own science adventure, check out the video on the RNZ website.
It's got all of the instructions that you will need to go ice fishing.
Have a go and let us know how you get on by emailing us at scienceadventures@rnz.co.nz. What do you do when you've caught the ice?
Oh, well, I don't believe in cruelty to ice, so I reckon we're just going to put them back in the freezer.
Thanks for listening to Nanogirl's great science adventure.
And thanks to Gary Wilson from Antarctica, New Zealand, and the cool folk at the International Antarctic Centre for helping us to answer this week's question. And a special thanks to Ashton and his friends from Casebrook Intermediate.
Listen to Nanogirl's great science adventure on Apple Podcasts, iTunes, Spotify, Stitcher, and most other podcast apps.
Click on the subscribe button and get every episode straight to your device. You don't want to miss next week's episode when we'll find out whether or not we can bring dinosaurs back to life.
If you have a great question, you can email us at scienceadventures@rnz.co.nz.
And if you've had a go at the experiment, send us a photo of the finished product.
This podcast couldn't have been made without Dr. Michelle Dickinson, Sophie Fern, Janet Van, Joe Davis, Crystal Lee Brown, Liz Garton, Anna Tovey, Claire Easton Farrelly, Pinky Fang, and all the incredible RNZ sound engineers, and our executive producer, Tim Watkin.
Nanogirl's Great Science Adventures made possible by the New Zealand On Air Innovation Fund.